Hello boys and girls, welcome to your intro to trigonometry, or as you're going to learn soon, SOHCAHTOA. SOHCAHTOA is just an acronym that will help you remember this stuff. We'll talk about it a little bit more in class. But SOHCAHTOA refers to trigonometric ratios. Trigonometric ratios are a ratio of the side lengths of two sides in a right triangle. The three basic trig ratios we're going to talk about are sine, which is the opposite side over the hypotenuse, cosine, which is the adjacent side over the hypotenuse, and tangent, which is the opposite side over the adjacent side. So you just find side lengths, plug them into these ratios, and you're good to go. If we look at triangle ABC over here, we're going to take the measurements from angle A. You can do trig ratios from either of the acute angles, but you wouldn't do it from the right angle. So the sine of angle A, so since we're dealing with sine, it's going to be the opposite side over the hypotenuse. So if we're standing at angle A, the opposite side would be lowercase a. The hypotenuse is lowercase c. So the sine of A would be A over c. The cosine of A, again if we're at angle A, cosine is going to be the adjacent side over the hypotenuse. The adjacent side is B, the hypotenuse is C, so the cosine of A would be B over C. And tangent of A, again we're at angle A, so we're looking at the opposite side over the adjacent side, so it would be written as the fraction A over B. Now let's take some examples of these with triangles that actually have side lengths in them. So we're going to find the sine, cosine, and tangent ratios for each acute angle in the triangle. We want to write each answer as a fraction and as a decimal rounded to 4 places. So as you can see, for triangle number 1, we want to do this for each acute angle. So first we're going to do it for angle A, then we'll do it for angle B. So if we're talking about the sine ratio, sine is going to be the opposite side over the hypotenuse. So the sine of angle A would be 8 over 17, which if we change it to a decimal is 0.4706. The cosine of angle A, so if we stand at angle A, it would be the adjacent side over the hypotenuse, which would be 15 over 17, which in decimal form would be 0.8824. And then the tangent of angle A, which is going to be the opposite side over the adjacent side, would be written as 8 over 15, or to 4 decimal places, 0.5333. Next, it wants us to do it for angle B, because we're doing it for each acute angle. So if we're at angle B, our hypotenuse stays the same, but now AC is the opposite side and BC is the adjacent side. So our sine would be opposite over hypotenuse, which is 15 over 17, which is 0.8824. Our cosine from angle B would be adjacent, which is 8, over hypotenuse, which is 17, which gives us a 0.4706. And the tangent of B would be the opposite side over the adjacent side, or 15 over 8, which would give us 1.8750. Now for triangle number 2, we'll start with angle R. From R, again 65 is our hypotenuse, 16 is the opposite side, and the adjacent side is 63. So if we start with our sine ratio, which is opposite over hypotenuse, it would be 16 over 65, or 0.2462. The cosine, which would be the adjacent over the hypotenuse, is 63 over 65, which would give us 0.9692. Tangent from angle R, which would be the opposite side over the adjacent side, would be 16 over 63, or 0.2540. And then if we go back to angle S, which is the other acute angle in our right triangle here, again, 65 is still our hypotenuse, 63 is now opposite, and 16 is adjacent. So our sine ratio, which is opposite over hypotenuse, would be 63 over 65, which is 0.9692. Our cosine would be adjacent over hypotenuse, which is 16 over 65, or 0.2462. And the tangent is 63 over 16, opposite over adjacent, which is 3.9375. I hope this all makes sense to you when you come to class. Next time we will be seeing a music video, getting triggy with it, which will explain even more.